All right, I am just getting your bio.
Okay. We could just skip that and save a minute.
No. All right, please help me welcome Lisa Meline. Lisa Meline is a licensed professional engineer in 4 Western states, lead accredited professional, and a certified GeoExchange designer. Lisa is chair of ICHPA's Standards Committee. ICHPA is short for International Ground Source Heat Pump Association. Standards Committee and Standards Subcommittee chair for ASHRAE, TC 6.8, Geothermal Heat Pump and Energy Recovery Applications. In her spare time, she serves as both rugby and soccer mom.
Go Lions!
Lisa Meline.
Thank you all for sticking around. This is there's a lot of information that's been shared with you today, and as I was watching the presentations, I thought, wow, I don't have to talk about that. I don't have to talk about that. So this could be a really quick presentation. Before I get started, I want to let you know that in your outline, there's one bullet there I'm not going to be talking about, the RPS goals. I couldn't really make that fit with the assignment that I was given for speaking, so if that's what you really want to hear about, it's a good time to get another cookie, okay? Okay.
Hold on.
You got me?
Now try.
Hey, so let me just set the tone for my talk. I'll give you a chance to read that.
Oh man, what's coming up? Nobody's first.
It's 3:45. It's 3:45, and so I'm going to try to keep this a little bit light. Steps to net zero energy. These are things that you've already heard a lot of the other speakers talk about. And one of the things that is really important that when I get a lot of calls, obviously people wanting to do geothermal heat pump system design. And, you know, I have this fixed budget and et cetera, and I say, well, you know, here's the thing. I'd really love to do a design for you, but if you only have X amount of dollars, go improve your envelope. Put in better windows, put in better insulation. Those are the things you really want to focus on. So, you know, that's really where it has to start. The second thing is conservation. Now, one of the things that always kills me is, you know, we do these geothermal, solar thermal, net zero energy homes, at least, well, maybe not so much net zero energy, but you know, there are these huge houses and we're trading off these Bay Area views for efficiency with heat pumps. Really what it comes down to is you have to be committed to doing some conservation on your own because, you know, use is going to translate into cost. And you can do all these other great things, but if you're not conserving and setting that set point where you told me you were going to put it during the design phase, you're not really going to be saving. So two of the top 2 things on my list. The other things we've really talked a lot about today, so I'm not going to dwell on them. You know, this is pretty much the process that you need to go through. So I'm going to jump right in. I want to share a project with you that I've been working on and off for about 2 years. I was very grateful to have some help from Canon Design. They're the engineer of record for this academic core building project at the Fremont campus of Ohlone College, which is just a little bit north of here down the highway. This is a picture of what they're hoping to get to in about 2.5 to 3 years. The lead engineer on the project, Jeff Nudi, and that's spelled N-U-D-I, had just coincidentally just done a Zero Net Energy presentation, and he was featuring the project. So I'm fortunate to share some of these very nicely done slides with you. Before we get into going through the process, though, I need to kind of give you some background on the project. It started off with a vision by the administration there and the, at the time, director of facilities. They really wanted to get the campus to a energy neutral is kind of how they defined it, rather than Zero Net Energy. They were looking at ways to do that. And so the first thing that typically is done, as you've heard with some of the other projects, is a life cycle cost analysis. And in that analysis, they started off using the base case, which is pretty much what they have now, a very much distributed mechanical system. Every building was built, has its own system. It has, you know, air-cooled chiller, water-cooled chillers. There's some buildings with water source heat pump systems. So you've got a little bit of everything at this site. And that was the baseline. That's where they started their comparison. The first alternative they looked at was taking that into a central plant system. They were going to look at air-cooled chillers and electric boilers, and I said, whoa, this is California. But that's how they modeled it, because as you'll see, they have 1.1 megawatts of power already on site available to tap into for their central plant system. The second alternative they looked at was a water-cooled chiller central plant system with electric boilers for heating. And then the third option was reversible chillers, electric boiler backup, and connection to a ground loop system. And so that last option is where we are moving ahead with design. So obviously what we have to look at first is how much energy is consumed by the buildings, by the people teaching and learning at this site. We've got to look at the renewable energy, and as I mentioned before, they're very fortunate to already have spent a lot of money on a PV array, so they've got some on-site generation that they can use to help determine how they want to move forward with the design elements of this particular project. And just also give you a little bit more background, there are multiple buildings at this site, and what they're doing is tearing down some of the core buildings. They're building 3 buildings and calling it the academic campus core, and within that is a central utilities plant. And that central utilities plant is going to be providing chilled and hot water to multiple buildings, but not all the buildings on the site. I mean, obviously you have to look at the cost effectiveness of going out to some of your more remote buildings on this particular campus. And so, you know, we're looking at how much energy we're going to buy from the grid, how much we're going to get back. And the idea is that we really want to be selling more energy back to the grid than we're using. And actually, you really want that to be neutral. So the way that that's done, setting targets, is benchmarking, and some of the other folks spend a lot of time talking about this. For this particular site, before I get into the benchmarking, I just want to mention, here in California, there is AB 1103, and I'm sure most of you in the room are familiar with this. If you're not, just Google www.ab1103.com. It'll give you some background, and basically what that says is thou shalt benchmark all non-residential buildings greater than 5,000 square feet. So that's basically where you need to start, and the rules and requirements for that are within that legislation. So, you know, you've got to set an EUI target. There's a lot of things that go into looking at what you can achieve, doing some energy modeling, looking at what you have at the site, looking at where does it make sense for you to go. For this particular site, they set some pretty challenging goals. For colleges and universities in general, the EUI kind of average is 120 kBtu per square foot. The regional average for this particular location is about 75, and Marcus, you probably know a lot about this as well. And their target for this campus is going to be 28 kBtu per square foot. Now, keep in mind again that this is just 3 buildings out of a very large campus. So you've got to kind of look at the weighted average for the whole site. A lot of the things that they plan to do, actually it is out for bid right now, my understanding, or actually it's in DSA, so it'll be out for bid soon. A lot of the things that you heard the other folks talk about, so I won't go into that, but obviously it's more than the mechanical system. It's lighting, it's landscaping, it's water consumption. And this is the part that I've been spending most of my time with. Which one? This one here?
No, the laser is the small one.
This one? Okay. So I've been spending a lot of time on this little brown blob here, which is the ground loop. That's how I'm involved in the project. And there's been some real challenges with that I won't really go into. I will tell you that it's in Alameda County, if that helps. But you can see here we've got our reversible chillers in the central utilities plant. We're making either hot water or cold water and distributing that to the different buildings that are going to be connected to this utilities plant. We also have this boiler. They insisted on having a boiler, but it's a gas boiler. And after looking at the loads and talking to the engineer of record, it's like, no, I just really don't think you're ever going to turn that boiler on unless both pumps to the heat pump, both pumps to the ground loop fail. Then you would definitely have your backup to that ground loop system for heating. Finally, they show a fluid cooler, which is making it obviously a hybrid system, and that's where we would waste any heat that we wouldn't be able to use either first by dumping heat to the pool that is used there, which happens to be right next to where these buildings are going to be built. And obviously, we would only dump that heat if the pools were calling and all, that was something that would give us advantage. But then we have the ground loop. So primary heat rejection is the pool, secondary is the ground loop, and then finally we have an opportunity to waste that heat if we have a really peak cooling day. But for the most part, the way this is set up is it is energy recovery. We're trying to do heating and cooling kind of simultaneously with this particular design. As I mentioned, I don't know if you drive down Mission Boulevard, you might even be able to see this. This is a huge solar array that they've had in for several years now, and their calculations are showing that the on-site generation is going to be more than what they're going to need for this new academic core buildings. But again, keep in mind, it's not for the whole site, so there's still going to be a positive energy use by some of the other existing buildings until over time those buildings can either be added to the central utilities plant or demolished or rebuilt or their systems improved. So one of the things that I struggled a lot with is whose definition to use for zero net energy. I showed you kind of what they did for this project. Kind of makes sense, energy out, energy in, you want that to be zero. I went to the NREL, I went and did some searching, getting ready for this presentation. I found a study that was done in 2006 where the NREL people were trying to decide what that is going to be. And I found this interesting table that talked about some of the things that you would want to do as far as priorities towards reaching this goal. And, I'm looking at this and I'm thinking, gosh, there's something missing. Oh, yeah, geothermal heat pumps. So, but where to put them, right? Where do you put them? That's kind of one of the challenges that we have for the folks in the industry is, are we energy efficient? Are we distributed generation? Are we on-site generation? Depends on how you look at that. So I like that this is my plug because Doug's here, and I'm trying to get brownie points with Doug because my dues are coming up soon. Geothermal heat pumps, one thing that we look at is its generation avoidance. Because they're energy efficient, because we're shaving kilowatts off of during peak times. Actually, we're always shaving kilowatts off of. The way I think about it is, for every ton of cooling installed, we're able to shave a half a kilowatt off per ton of installed equipment. And so that's something we're doing all the time, whether it's peak time or off-peak time. So that's generation avoidance. That allows us to help level the electrical generation demand, which is something I'm going to show you a slide reflecting later in the presentation. When done simply and properly, they can be energy efficient. Just because you put a heat pump on doesn't mean it's going to be efficient, and that's one of my pedestals that I like to get on. And then out of sight, out of mind. Once my ground loop's in up at the Fremont campus, the dirt's going to be piled over the top. It's going to be, you're not going to even know it's there. And if it's done correctly, you should never have to even touch it again. This is a simple geothermal heat pump system. You guys are probably all familiar with this. The 3 key points to remember is obviously you've got, in this case, a residential system. This would be a packaged heat pump, either making warm air or cold air. You've got your ground loop system that's out, and this could be any kind of ground loop system. It could be a slinky, it could be horizontal, it could be drilled, it could be a pond, it could be a lot of different things. And then you have your pump, and that pump's really important because you can pick a really nice heat pump. You could put in a really efficient ground loop, but if you oversize that pump, you've just ruined all that energy efficiency that you've worked so hard to create. Now, you've seen this slide before, and the only thing I want to say about it is my numbers are different, right? Remember Paul? Remember his numbers? Okay, he's a marketing guy, and I'm an engineer. I'm going to go with the conservative numbers. So for every kilowatt of energy that you purchase, you get 3 out of the earth, and then we're looking at heating mode here to deliver 4 kilowatt of heat to your building. So, okay, if this is the case, then isn't the Earth essentially generating energy, right? Are we on-site generation? Well, technically, no. I mean, yes and no. What we're doing is we're actually storing energy on the, under the building, on the site. So in the wintertime, we're using the energy that's been, actually I got this backwards. In the summertime, we're putting heat into the Earth, right? And in the wintertime, we're pulling it out. So what we're really trying to do with geothermal heat pump systems are have a balance. We want to try to put as much heat into Earth as we're going to need to pull out later to heat the building. And that doesn't always work, but that's really the goal, and that's what we're working towards. So over the course of the year, we have net zero energy use on the ground loop. Now, I'm not going to read this. I'll let you read that if you want to. I borrowed this slide from my mentor. And one of the things I like to point out again is just because you put in a geothermal heat pump system doesn't mean you're going to be efficient. Because I belong to ASHRAE, I get the opportunity to read a lot of technical papers that are going to go in for publication. And, you know, one that I just saw recently that they tried to blame the inefficiency of the building on the heat pumps. Oh, we put in a heat pump and that just didn't work. And I thought, wow, and I started reading the paper. It's a 350-ton system and it has 70 vertical loops. I wonder why that heat pump isn't working. So there's a little bit more to it. I just want to let you know that just because you, in California, meet Title 24 requirements, that's minimum energy efficiency, okay? That doesn't necessarily mean you're going to have the most energy efficient building. Just because you have a LEED Platinum building doesn't necessarily mean it's going to be energy efficient. It means you got a bunch of points. It has to perform. You have to show it over time. And that's one of the things that I think net zero energy does for us. At the end of the day, at the end of the year, you look at the power bill. Is it zero or not, okay? Doing a little more research, the ASHRAE vision on net zero energy, their big paper that they did in 2008 was actually the ASHRAE vision. And what they're looking to do is provide tools by 2020 so that they, let's see, what is their wording they use? So to enable the building community to produce market viable NZEBs, net zero energy buildings, by 2030. So they're still tapping into that same timeline that we have in California for the big, bold goals, 2020 for residential and 2030 zero net energy for commercial buildings. And here's the definition that the CEC has for net zero energy. I'm not going to read it, but I do have one question. I don't understand societal value. So I think that's subject to interpretation, and I'll just leave it at that. Okay, National Park Service. This was the project I really wanted to share with you today, some data. I've been pestering this poor architect for the last 6 weeks trying to get data. All she's been able to tell me is, yeah, I think it's working pretty well. You know, nobody's calling me, and I think they're pretty happy. So instead, I'll just tell you a little bit about the project. This is an interesting project because I was kind of brought in at the 11th hour. And in fact, I think it was the week of Christmas, like 2008. And they were to the point where they needed to put in the ground loop system, and the engineer on the project just wasn't comfortable doing it. So they called me and they said, hey, can you have that done by January 2nd? So guess how I spent that Christmas break. But in any event, it was a really interesting project. It was 3,400 square feet. They put in a horizontal slinky system. They had a central plant system, if you will. It's a relatively small building. It's basically student housing for summertime when they have a lot of interns up here. This is actually located in Southern California in the Santa Monica Mountains. It's actually very beautiful up here. They designed for a water-to-water heat pump to provide either hot water or cold water to fan coil units in each of the buildings, or each of the residential units and the common area. They had PV, they used electric water heating, and they actually had this device they put out. I didn't really understand it, but it was basically collecting the gray water, treating it, and then what they decided to do at the end of the project was actually pump it out and let it drain over the ground loop to help provide some additional moisture to encourage heat transfer for cooling in the summertime. And you'll notice that this project also has, what do you call it, drought-tolerant landscaping. basically dirt and weeds. All right, so here's what the project looks like from the back, and all I want you to notice is PV panels, dirt, landscape, dirt with weeds. Actually, under that landscape is where the ground loop is. And normally, I would not design a slinky system for a commercial type project. The only reason I agreed to help them size the system when they called me right before Christmas was I needed money to buy Christmas presents. No, that's not right. I agreed to do it because, first of all, this is really a housing project. It's really student housing. It's like a residential project, so that was okay. Second of all, they kind of already made plans to put that ground loop in this location, and they just need to know how many would fit, right? We have this hole, how many do you want to put in? And the third thing was that the worst case scenario, this was 8 feet below the surface. On the best case, it was 11 or 12. So it was rather deep, more down in that deep earth temperature, so I wasn't as concerned as if it had been much more shallow. Other projects, we've done some over in Nevada. I won't get into that because I want to try to make up time because I really want you to hear what Doug has to say. They've done a central plant system up at City College San Francisco. You probably know about that already. Let's transition from public projects to neighborhoods. There's actually been quite a bit of talk about this, so I don't want to spend too much time. But, you know, like I said, there's a lot of different ways to get there. The goal for zero net energy homes by 2020, the California Energy Commission has already kind of taken that one on with the solar ready. You know, California, why would you not do solar, whether it be PV or a solar thermal panel, which I have on my house, I love because my teenage son, as you heard, plays rugby. Do you know how many times a day that kid showers? I'm telling you that solar hot water panel is the best thing I ever invested in. Passive house is another strategy, just, again, working with the building elements, right orientation, looking at where you're actually putting the water heater relative to the hot water use, some things that are very common sense if you just sit back and think about it. And then there's several programs that are helping to encourage for better performing homes, such as this home performance program. It's much too bad Bruce already left. So now let's talk about businesses. Well, everybody knows that geothermal heat pumps don't work in South Lake Tahoe, right? Yeah, so for those of you on the webinar that can't see me, this is actually sarcasm. Yes. This is a project that we did several years ago that actually is performing very well. In fact, the ground loop temperatures have never gotten down below the design that we had set forth. It's not a net zero energy building, but it's a nice picture, and it allows me to go to this next slide, which I really kind of already talked about, is, you know, how do you measure the efficiency with net zero energy buildings? You know, if you can't measure it, you can't manage it. If you look at your power bill, your annual power bill, you'll see whether or not you're going to meet that goal. An early adopter, this is a project some very nice people up in Upper Lake had been spending a lot of their weekends up there, and there's an old hotel there that they fell in love with, and they decided that they wanted to fix that up so that people could come enjoy the particular community that they've enjoyed so much over the years. They are looking to retire up there. They restored the hotel, they built a restaurant, they added some additional buildings. They put in a pool, a spa, and some oforos, which are Japanese hot tubs in several of the rooms, or outside some of the rooms. I called them, these are some pictures of the actual facility. I called the owner and I said, you know, I'm going to be talking to these people about net zero energy, and, you know, since that's really what you guys were trying to do, you bought all the PV that you could and you put them on this hotel, and you put in geothermal heat pumps, and I think we designed a pretty efficient system. Basically, it's a primary, secondary loop. We circulate with a small 5 horsepower, and variable speed drive? Well, no. We've got it set up. Okay, 2-speed. It's basically, this pump is the heart of the entire system. We're just circulating water by all of these buildings, and as those buildings need to transfer energy from their heat pumps in the buildings, there's a small little circulator that that makes that happen. So it's a really pretty simple system compared to some of the other things that you may have seen today. But so I talked to them, and they said, well, there's a couple of things that I would do differently. He said, I wouldn't put water heat pumps in a sleeping room. I understand that. They kind of hum a little bit. He said, you know, we've been really happy with the system. One of the frustrations that they have is they can't understand their power bill. Apparently, however they set up their PV and their metering, they're not able to determine how much power they're actually generating. All they know is what their power bill is. And so I don't know, I tried to help them at one point, but I'm a mechanical engineer and I'm an electrical engineer, and they've never been able to get that piece of the puzzle kind of resolved. So I don't know anybody who does PV, but it seems to me like you should be able to know this, right? I mean, is that so hard? What I generate versus what I'm paying for. Anyway, so then the last thing that he said, and I wanted to share with all of you, is one of the concerns that he had that I would pass on for people that are getting into zero net energy and these technologies, some of them off the shelf and some of them kind of out there and to be proven, is he said, you know, there aren't that many people who know a lot about geothermal heat pumps. I'm limited to, you know, 2 guys in my area. And so we're very limited. It would be nice if there were more education, there were more information out there so that we had, you know, more contractors and homeowners that had better resources to help them to maintain these projects and their kind of out there systems, or at least that's how it's perceived. So I thought that was really interesting. But in general, they're very happy with their system and they feel like they are getting the efficiency out of it. So now this is the last thing I'm supposed to talk about. How to identify and hire a competent design team. And that was kind of my lead-in from talking to the owner at that hotel. You know, how do you do that on the design side, not just on the contracting side? Well, according to Edward Deming, in God we trust, all others bring data, right? Show me the data. You know, if you are out on a job site and the engineer drives up in a shiny, nice, clean Land Rover, is wearing a pinstripe suit and shiny black shoes, and he's coming out to talk to the contractor about his project, I'm thinking that guy is more flash than fabulous design. I mean, I don't know, but there are things that make a competent design team are more skilled than just marketing. And marketing is important, but the proof is in the pudding. Like I said before, you've got to be able to deliver these designs that are more than just slapping a rooftop unit on top of a building. You've got to design for maintainability. I mean, that's one of the things that I struggle with all the time is the architects never give you enough room for the equipment, right? Well, it's our job to push back on that and try to think about those poor guys, especially in the schools that have to come fix these systems that they can't even get to, or they've got things in the way. So even if they wanted to say change a filter, they can't get to it. We want to keep the designs as simple as possible. And I have to say that one of the things I have noticed in a lot of the zero net energy stuff, and especially when I first got into ASHRAE and it was getting to 50% better than 90.1, is a lot of those systems included geothermal heat pumps, and a lot of them did have some complicated controls. So those are some things we need to really think about, you know, what I think the gentleman that left there in the back, the architects, you know, you really need to talk to the owner. Do they have the ability, do they have the staffing to be able to maintain these systems if we design them to meet all these energy goals, but nobody knows how to work them or fix them or get in there and play around with the programming. The competent design teams are going to have some kind of track record. They're going to have data. There's an example of an engineering portfolio that one of my mentors has recommended. And, you know, what are their ENERGY STAR ratings? That's a benchmarking tool. Ask the engineering and architect team to share, you know, show me the ENERGY STAR scores for your last 5 buildings. Let me see how your buildings are performing. That's a lot. You don't have to read it, but this is anything you would want to know about this particular project, the square footage, how much the system costs, how it's performing as far as power bills, and some details about what actually went into the project. You know, this is just one version of an engineering portfolio. And here's that slide I wanted to share with you. This was from a friend of mine's engineering portfolio, And this was a school that got a Energy Star rating of 98. Just so that you know what you're looking at, the red and the blue lines is the energy data, kBTU per square foot, for this school in Belvedere, Illinois, for the 2 years prior to the system being retrofitted with the geothermal heat pump system. The original system was a central boiler that provided hot water to unit ventilators in several of the classrooms. The new project came in, pulled out the boilers, put in a central pump, replaced all the unit ventilators with individual water-to-air heat pumps, and so now these teachers are able to teach in classrooms that have not just heating, but heating and cooling. And here is their kBTU per square foot number. And that's what I would call leveling of the energy consumption. I would think that would be something the power companies would be interested in. So to be successful, find a design team that you like and think you can work with. There's going to be good times and bad times, and I think a lot of times how engineers and architects come out of adversity in the design project is just as important as getting the awards at the end for the excellent design. Ask for examples of their work product. Make sure the engineering team is experienced or at least willing to learn. I mean, if you ask an engineer if they know how to do this kind of design, they're just going to say, sure, I know how to do that. But if they don't, are they willing to go out and learn how to do it? Go read a book, go to a seminar, take a class, because, you know, some of these technologies can really be foobarred if you don't know what you're doing. Again, ask to see their portfolio of Energy Star scores or just data. And, you know, look for the practical engineer. Look for the guy, pocket protector. Maybe he's got the New Balance tennis shoes at the job site. And if you see these, you know, shiny black shoes, run the other way.
I will point out, Lisa, your shoes are black and shiny. I'm not sure if...
and I knew somebody was going to say that, but I am not at the job site, and I do not drive a Land Rover.
All right, good point.
All right. One last thing to add, which I think is super important, and I don't want to dwell on this too much longer, but user education is just as important. When you go through all these steps to get to net zero energy, but if people don't really understand the technologies, if they don't know how to operate it, it's all for nothing. So that is all I have. I'll leave you with this final thought, and thank you for your time.
Are there any questions? You have a question here?
For systems installed in Hawaii, there's no winter or northern of the Canada in the summer. Can they be installed geothermal?
They do all kinds of geothermal projects in Canada. The difference in Canada is that they're typically looking at systems that are heating dominated instead of cooling dominated like here. So if you weren't able to put enough ground loop in the earth, you would look at a hybrid system using like a boiler or solar or something like that as your backup. In Hawaii, I think that would be a little bit more challenging. You probably wanted to put all your heat rejection from your air conditioning into domestic hot water or something